Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, I'm gonna go back to the topic of cylinder hacking. It's basically kind of like a way we can modify a cylinder so we can have control how over the components of the cylinder to generate this kind of result, and then kind of using it for our edge duplications. You can get this kind of result very quickly. So yeah, let's get started. So basically, this was inspired by kind of example from one of Spreadshot developer Zeffii. He showed me an example how to access the cylinder without using the more like math kind of way. So I'm gonna try real quick. I call it cylinder hacking because it's easier to think of it that way. So we have a cylinder nodes, and you know that a node is something that's already been created and contained in a nice way for user to use, but you can actually go inside the node and kind of make a modification yourself. That's actually the strength of Blender and Spreadshot add-on, because you get access to the source code and you can have a look and then you can study it and then make modification to your need. So we know that cylinder already give us these parameters: separate, caps, radius top, radius bottom, height, vertices, and subdivisions. But we want to be able to control each part of this circle that made up the cylinder, and we're gonna take a look at that again, but in a different way. In the previous live noding, I talked about the same thing, but let's do it this way. I'm gonna show you real quick. So we have two subdivisions from top bottom, and then we have the vertices. Make it small for now, just 8, and then apparently we can go and separate the vertices and then kind of accessing the circle this way. This is a trick that's shown by Zeffii. So you can separate the vertices like this, and then if you want to modify just the X and Y, you can do that pretty easily simply by combining the X and Y into another vector, and then use a vector math in here with multiply scalar. And after we do that, just separate this guy once again and combine it back. This is actually possible because cylinder itself as a structure, as a primitive, is made of this kind of structure or system. So there is some kind of pattern going on with the data that's made up of the cylinder. We don't make changes to the polygon data itself or nor the edge data, but we simply can access the vertices data quite easily using this kind of separation of vector and things like that. Okay, so we find out about this. I actually show you about this too at some point, but if you try to randomize the vertices right now, just plugging in, just using like a random number generator like that, you will see that this doesn't quite work right away, because what's going on is it's kind of pushing the vertices separately. That's not actually what we want. We want to control the vertices based on as a group, like as a group of circle. So we need a way to separate that. Okay, for that I need to kind of make like a repetition. Let's say we have subdivisions of 2, so maybe we need to provide 2 or maybe 4 um, let me think how to explain this. Currently we have 4 numbers. I'll use fewer text to be clear and display the data. So the data looks like this. If we have like we have 1, 2, 3, 4. So okay, we provided 4 numbers. If we want to control these points as a group, that means we need to kind of repeat 1, 2, 3, 4, 5, 6, 7, 8. We need to repeat these numbers 8 times for each of this number. I'll show you. So we need to use maybe like list repeater, and let's see, what do we have now? List repeater maybe 8 times. So we have these numbers. This is probably not correct. We want to repeat each number, not as a list. So we need to probably unwrap it, or level 2. Level 2 is actually correct. So level 2 and unwrap. So we have these 4 numbers which is randomly generated being repeated 8 times, and so we have all this like a group of numbers that we can simply join back. List join, and I think list join level 2 actually put them all together. It was like this, and then with list join we combine all of them into one. Now I think we have the number that we can simply use. So it's actually that simple. It's really that simple, as long we know there's some kind of pattern inside the cylinder that we can kind of hack. So what's happening is I'm using random number generator and generate 4 instead of 2 because we have 2 extra points top and bottom. So you have to remember that with cylinder you need to remember with the subdivision you need to always add 2. So if we have 2 subdivision, we need to add another 2 in order for this to work and plug into the size of random number generator. Now this is actually correct. So whatever number we provide, this will get passed into the cylinder, and using the list repeater and list join, we manage to repeat the number depending on the number of the vertices here. So we need to actually assign this same number here into that guy. Actually not to height, but to the vertices. So the height still user have control on the height, can control also this subdivision along this horizontally and then also vertically. The number, random number being generated on the fly, and then everything else will fix everything like accordingly. Everything will update accordingly. Basically, you can always see the number here. This is the number being generated. So how many do we need? Maybe just 5. 1, 2, 3, 4, 5, 6, 7. 5 plus 2 is 7. So we have 7. 1, 2, 3, 4, 5, 6, 7. Okay. And then we have this random number. It's being repeated. So that's the repeat is for the points along each circle, and then we join all of them again. So I just keep the viewer text like this so we can see the numbers being used. So 0.9 probably at the bottom, and then 0.25, 0.26, 0.24, and then etc. So we have this result. Very cool, right? So we have a cylinder that we can with an additional parameter. So I wish this can be like a cylinder 2, cylinder 2. I call it cylinder 2. So apart from random number, of course, we can also provide a different kind of number pattern. Let's say you want to use like a sine wave, that's also possible. So instead of this random number, let's say if we want to use sine, use math sine, this function. So this function alone, depending on the input, will give you a single number. But if you provide it with a range of number using range float, let's see, the number, the count should go to this guy, and then the output of this goes to the sine, and so we have this number. This is only based on this count, 5 counts between start and stop. It's really up to you how you want to control this range of number. But anyway, the result of this sine can go into this repeater, and let's join once again. So we end up with the number that we can use. See, this is the number 0000 being repeated, and then this number being repeated, etc., etc. All we need to do is just to plug that in, and then supposedly we get a, oops, I clicked on the wrong thing, sorry. If we've done everything correctly, we should get the result we need. So this one 140. Oh, okay, this number. I need to plug this one into that one. And this guy, so this one goes into that guy, or sine wave, and then we have this count, maybe the step. Okay, there you go, I think it's working. I forgot to add this 2, that's why, see, the last 2 circle is not getting anything because of this. I forgot to do this add. So now it's working correctly. You see the sine wave, sine function goes in and out, so it's working. The sine actually goes into negative value. If you don't want that, you need to adjust this. So use math, and then actually maybe use map range and control this -1 and 1 to 0.2. So I changed the number so it never goes under 0. Okay, now if we grow our cylinder and increase the subdivision, maybe in this axis, we're gonna get a totally different kind of cylinder, and we still have control over radius top and radius bottom. See, this is really powerful. Let's get rid of this viewer, get rid of the points, we just look at the cylinder. Cylinder is, of course, it's not like if we are using loft, like if we're drawing like a profile like this and then do a lofting, that's another different way to generate something like this. But because we are working within a cylinder and only adding parameters to the cylinder, revolve is another different story. But now you can see that you can easily get inside the cylinder and do this kind of thing. So this is really powerful. in fact, whatever functions you give it, this will update itself. So whether you want it random for the cylinder, or you want assign functions, or perhaps you want to have something even something different, like provide your own functions, or maybe you want to use like easing function. This will actually work as well. So now we have like kind of like a viewer with this easing function. This is really cool. We can simply plug in this guy to the data, and it will update. It will actually work depending on the function. Sometimes it goes outside the boundary, that's why you don't see like much changes. But the sign is in works. Maybe with this function we need to give it like the value between 0 and 1. See, start stop 0 and 1, and so we get a result. This is linear interpolation, quadratic, and then etc. etc. I think this is really cool. So you're applying the functions to scale the circle of each cylinder. Maybe change the height. Actually, maybe I could like multiply the function right here, or repeat the function even. Maybe list repeater, or maybe math multiplier, and no, multiplier give that kind of effect. Maybe if it's smaller than 0, no, same thing. Exponentially, no, exponential give you that kind of effect. Maybe modulo. Modulo actually kind of repeating the thing. If we have more resolution, maybe. See, modulo give you that very unusual kind of design. F function, F mode. I hardly ever use F mode. Sign. Easing, maybe list repeat. Actually, it's maybe not a good idea. Nah, there must be something. Oops. There must be one functions that allowing us to do a repeat of this easing function to repeat the curve. I think modulo is the answer. Yeah, I kind of like that. So we can actually leave it over there. I'll keep it simple. Just use bounds, or okay, I'll use linear interpolation for example, and then we can actually use this guy, this cylinder, for other purpose. So this is a bonus. So you can kind of draw like a grease pencil here, and then convert the grease pencil into Bezier curve, and you have this curve. And the next thing you can do is to use object in, get the curve, and then use the interpolation. We sample the curve. I'm gonna do it really quickly. And then you look at the result. We turn it into edge, increase the sampling, and once we've done that, we can really use the duplicate objects along edge, use the edge, and then change this to Z, and then just simply plug in the cylinder into this guy, and by some kind of magic we get this result. Maybe I'll hide the point. There you go. It's a bit high res. I'll reduce this number 12. This one can be 4, maybe 12. This one can be 6. So we get a lot of sampling there. So maybe reduce the sampling. See, it's really simple. Change the count to 1. See this guy replacing the edges. There's some kind of a rotation, slight rotation problem there. But you get the drill. This we are replacing each edges of this grease pencil strokes with a cylinder. Yeah, I think that will work. So yeah, that's pretty much it for this live noding. It's pretty interesting. A lot of concepts put together, and yeah, I guess if you have any questions, suggestion, feedback, just let me know in the comments below. And thanks again for tuning in, and I'll see you